Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the series of videos on the normal distribution, and in this video I'm going to be going through a slightly more complicated example using the normal distribution to find probabilities. So we have a bit of a situation here. The weight, W grams of tinned peaches put in a tin by a machine, is normally distributed with a mean of 220 grams and a standard deviation of 5 grams. So I've written that in the notation there. W follows the normal, 220, 5 squared, and I've drawn a normal distribution, popped a line down the centre for my mean of 220. Now in part A, the first thing I'm being asked is a tin is selected at random, find the probability that W is less than 227. So what I'm going to do is just pop a line on my diagram at 227, and it's the probability that W is less than that. So if I shade in the area to the left of that 227 line, straight away I can see that I'm expecting an answer greater than 0.5. So something to check first off. I explained in the previous video how to use the class whiz calculators to find these answers, so I'm not going to go through all that again. I'm just going to give that the answer to 4 decimal places is 0.9192. If you're not sure how to do that, you need to go back and watch the first video in this series. Right, looking at part B then, we're being asked to find the value of W such that the probability that that W is between 220 and W is 0.4. So I'll just pop that there. So between 220 and a value of W is 0.4. Right, I'm just going to draw a new normal distribution, or a copy of the same normal distribution, but I'm going to draw another diagram so I don't get confused with what I'm doing. So there's the normal distribution curve, and there's my centre line for the mean at 220. Now, the probability that W is between 220 and this value W, so that implies that W here is going to be above 220, so I put W over here, and we're being told that the probability of that happening, so the area of this blue shaded region, is 0.4. Now, I'm going to have to use the inverse normal function here to work out what the value of W is, but I can't give it the area 0.4 because that stops at 220. I need to give it the area of everything to the left of the line where the value is that I'm trying to find. Now that's going to include this area here, which is everything below the mean. Because the mean is the centre point, everything to the left of the mean must be 0.5. So if I go into my inverse normal function, that's menu 7, option number 3 on the calculators, I'm going to need to tell it that the area to the left of the line that I want is 0.9, that the standard deviation is 5, and that the mean is 220. And if I put that into my inverse normal function on the calculator, it tells me that the value of W is 226.4, which makes sense. It's above 220, so I'm happy with that. Right, then part C. The probability that W is less than the mean, given that W is less than 227. So I'm going to draw another of the same normal distribution, each new question, new diagram, so you've got uncluttered thoughts. Always pop in that little line for the mean at 220. And we've got the probability that W is less than mu, the mean, given that W is less than 227. Now if I pop that line in at 227, I know that this area here, to the left, there's the probability that W is less than 227. And I already know that from part A of the question, was 0.9192. Now what this question is really meaning, the given that means we already know it's less than 227. What's the probability that it's also less than the mean? So we're only choosing now out of this section of the normal distribution rather than the whole population. So the probability isn't going to be out of the whole thing anymore, it's just going to be out of this. So what we're actually going to work out for the probability that W is less than the mean, given that it's less than 227, we're saying what's the probability that you're in this bit, given that you're already in the blue bit. So I'll just shade the bit to the left of the mean. So what's the probability that we're in here, given that we're already in here? Well, the probability that we're in the red bit, below the mean, is 0.5. And the probability that we're in the bit below 227 is 0.9192. Now what I'm actually just going to do with this is just multiply it through by 10,000, numerator and denominator. Because what I like to say to my students is, okay, well imagine instead of 0.9192, imagine that this is 9,192 people, or in this case, tins of peaches. What's the probability that out of those 9,192, they're less than 220? Well, 5,000 of them, half of everything, is below that mean, out of the 9,192 that we already know are below 227. So that gives us our overall probability for this question, which is 0.5439. So that's part C. Now part D, very similar, the value of x such that the probability that W is greater than x, given that W is greater than 227, is 0.625. So part D, similar to part C, but in reverse. So let's do the same thing again. Let's draw out the normal distribution. Same one. So pop in the mean line at 220. So we've been told that the probability that W is greater than x, given that W is greater than 227, is equal to 0.625. So we're saying, okay, here's here's 227, and we're saying, what's the probability of being greater than x, given that we're already greater than 227? Well, if we know we're already greater than 227, x must be up in this section of the normal distribution. So straight away, x has to be more than 227. Now, the first thing I need to know is the probability of being greater than 227, because that's the area that I'm choosing out of. Now, I knew from the first part of the question that the area all to the left of this is 0.9192, so I'm going to need to do 1 minus 0.9192 to get this area here, which is 0.0808. So, probability of W being greater than x, given that W is greater than 227. The probability that W is greater than x, this bit here, given that we're already in here, so we're only choosing out of this area here, so the denominator is 0.0808, and we've been told that that equals 0.625. So what I can now do is I can multiply 0.625 by this value here to get a probability that W is greater than x, which is 0.05047. Now I can go back to my inverse normal, because I know that the area of this red bit now is 0.05047. So I can go to my inverse normal function, which wants to know the area, the standard deviation, and the mean. Now bear in mind that the area has to be to the left So it's going to be 1 minus that 0.05047, etc., etc. The standard deviation is, just going to check it was 5, wasn't it? Yes. The standard deviation is 5, and the mean is 220. And if I use the inverse normal function of a calculator with this information, it will tell me that the value of x is 228.2. Which makes sense. It's greater than 227. So probability of being in the red bit, given that we're already in the blue bit, was 0.625, and we've just calculated that that x value is 228.2. There we go. Thank you for watching.